thank you very much for coming. My name is Warski. I come from Warsaw, Poland. I work at Software Mill, and I would like to talk today about type API descriptions. So it's the first talk I'm giving on this library. The library is called Tapirs in Polish. I'm not even sure how you pronounce it in English, so maybe you can help me. How would you say that word? Tapir. Yes? Tapir? Something like that. In Polish it's an animal, like a pig, like a big difference. So here it will be about Scala Pokemon. So if you have any questions like how to talk, please let me know. Right? It's a meetup, so I guess we are not very concentrated. And we'll be doing some live coding. We will see if things work. I will try to do a very gentle introduction. If it's too gentle, let me know. If it's too fast, let me know as well. Okay, so let's start. So first, maybe a bit on what kind of problem we are actually trying to solve. That's slide 1. Let's go to slide 2. So Tapir isn't actually an HTTP framework, and that's an important thing to remember. So instead what we will be doing will be describing API endpoints. So it's a different API to describe the endpoints, but the actual task of running the HTTP server is delegated to an existing implementation such as HTTP or HTTP first, right? So then the question is, why don't we actually use HTTP, for example, right? And it's a good question. So, well, both of these are quite good in the task that are designed for, right? So they are designed for writing endpoints and exposing HTTP servers. But I'm not sure. Do you have any experience with HTTP or HTTPS? Everybody has, yes. More or less. Okay, so we are more or less familiar with how these things work. I have some examples of the end of the code that we are going to write using Tapir in the other frameworks, but we can save it for it. So they are quite good if you want to define the endpoint and the logic. But then comes a time when you actually want to generate documentation for your endpoints. And there isn't a good way of doing that either with HTTP or with HTTP, right? In HTTP you can add some annotations, but that's quite tricky to do right, and once you start doing dynamic things, it breaks. In HTTP4S you have a subproject called raw, which is, well, the syntax is weird to say delicately. So yeah, I think in this area you can do definitely better, right? If we look, for example, in the Java land, we have JAX-RS, which solved this problem a long time ago, right? So in the JAX-RS we have Java methods, which we annotate with Java annotations, right? And based on it, it's quite trivial to generate documentation. You simply have another interpreter running at runtime, reading the metadata, and generating the docs, right? However, well, JAX-RS has the obvious downside that it actually uses annotations. So annotations have a lot of, well, they did a lot of good in the Java end, but still I think there's a lot of things that can be improved about annotations. I wrote a whole blog about this, so if you're interested in that, if you Google my name and annotations, I think it should come up somewhere near the top. Like the first problem that we will try to solve is to be able to describe the endpoints in a nice way and still be able to generate documentation, but we will focus on Swaggle and OPI documentation here, right? Another option that I didn't mention is, of course, writing the YAML, because again, I'm not sure how much familiar you are with Swaggle or OpenAPI, but it's like a standard for describing HTTP endpoints using YAML. And well, YAML is very good for computers, and sometimes it's good for humans to read, but writing it is really painful, and I don't think anybody should really write YAML by hand, unless you are really mean. So we will try to avoid that. So another thing that we will also try to achieve is being able to generate clients automatically from our descriptions, right? So to do that, we will employ, let's say, a functional programming technique. That sounds fancy, but it's really simple at the core, as you will see. So what we will do is we will create a description of our endpoint, which will be quite a simple structure of a family of case classes. And then we will create, then we will use interpreters to turn the description of endpoints into a server, into a client, and into documentation. Okay? And that's really, as I will try to convince you, the functional programming at its core. Okay, so I think I don't have any more. I have slide 4. Slide 4 is about me. Sorry. So just a quick introduction, so you know who's talking to you. So as I said, I'm a software engineer and the co-founder of Software, which is a consulting and software development company in Poland. We are on the market for 10 years. We have a fully remote and flat structure. Our main specialization is Scala, but also Kafka, blockchain, and other fancy stuff. So if you are looking for short-term consulting or longer-term project development, Software is the place to come to. I'm also doing some open source projects like STTP, Tapir now, Tapir, Macquarie, and so on. Yeah, and I have a Twitter account, which isn't very surprising probably. Okay, so let's start with the demo. So we will start with a very simple hello endpoint. You know, just a hello world. So the first thing we will do is we will actually import the Tapirs package, which will give us access to some to the API. So now we will define a description of the hello endpoint. So we will call it hello endpoint. Okay. And to do that, we will start with an empty endpoint, which comes from the Tapirs package. It's for endpoint. No surprises here. Okay. I will explore in detail what the definition is of that value in a second. And now our endpoint will correspond to the get method. It will have a single input, which will be a query parameter, which is a string, and that query parameter is called name. So our name query parameter will map to a string, and in response, we will return a string body. Okay, and that's it. That's the description of our endpoint. So the first thing to notice is that the goal of Tapirs is to be programmer friendly and to create readable code. So if you try to read this description of endpoint, it kind of reads naturally, right? There's an endpoint, which is a get. It has a single input, which is a query, and an output, which is a string body, right? So it's more or less in English, maybe not entirely grammatically correct, but I guess even not knowing the library itself, you can more or less understand what's the intention. Okay, so now let's try printing this hello endpoint. It has a show method which will print a nice readable description of the value that we have just defined. The important thing here is that we have defined an endpoint and nothing really happened. Okay, so this thing here, it's just a value. Okay, so now there's no network binding, nothing like that. It's just a plain Scala value. If we print it out to the console, you can see that it corresponds to the description that we have created. Okay? So now, well, if you have a description of an endpoint, the first thing you might want to do is to expose it as a server. Right? So in order to do that, we need to start an actual HTTP server. Here we will use HTTP. We can also use HTTPS if you prefer. So there are two interpreters. By the way, the core library, which gives you access to this API, has no dependencies at all. The library which provides the HTTP interpreter has a single dependency on HTTP. Okay, so I will just copy the code needed to start the Akka server. So that's this one. Okay. So if you know Akka HTTP, that's like some very standard code which creates an actor system, creates an actor materializer, and then binds to port 8080, right? With the given rules, right? Now these rules are the Akka HTTP rules, right? So, and it's missing, you can see that it's red. So now we need a way to convert, to interpret the description of the endpoint as an Akka HTTP route, right? And we will do just that. So now we need to import the interpreter. So we will import Tapirs server Akka HTTP underscore. So this brings in an extension method which we can call on the endpoint description. So now we can say hello endpoint dot to root. To root is the extension method coming from the interpreter. So let's use that. And you can see that IntelliJ suggests a type. So it suggests that we should put a function in there, right? So in order to interpret the endpoint as a server, we need to provide the logic that should be run when that endpoint is invoked, right? So we have defined a single input parameter, which is a query. So our function takes a single string parameter, put here, right? Now you may wonder what's this over here. Okay, so since we are in Akka land, everything is a future, right? So the result is a future as well. If we are using HTTP press, the result would be wrapped in an abstract f, where f is a IO or task or whatever we are using. Here in Akka land, we are using futures. Then this string over here corresponds to this string body, right? So in Tapir, every endpoint can have an error result, a normal result, right? These are usually quite different. So the structure of the results that you return on an error is usually quite different from like the normal response, right? So we haven't defined an error response, so that's a unit. But we have defined a normal response, so that's a string. So here we need to provide a function which, given the value of the query parameter name, returns the body to give back to the user. So it will be a simple function taking the name, future, successful, right? Okay. And this will be assigned to roots. Okay. Now it should work as expected. So now the type of this value is an Akka root. Okay, so this is a root from the Akka HTTP model, right? We have interpreted the description as an Akka root, right? And now we can use that value over here. Okay, so let's try running it. Okay, so now we didn't HTTP 8080 name Adam, and it's worked. Well, I've done that work. Yeah, so things work. We can see that if we don't give the parameter which is required, we get a bad request message with a standard message that there was no query parameter. So things were more or less as expected. Okay, so is it clear so far? Yeah? Okay. Okay, so now let's move to some more complicated examples. So I will, to give us some data to work with, I will copy some examples from here. So we will work with a list of books. These are 3 books that have been published in the year 1992. Long time ago. Okay. So now we will generate an endpoint which is slightly more complicated. Okay. So we will describe an endpoint to get a list of books. So we will say get books endpoint is an endpoint, which is a get as well, and it has an input books, it has an input query int and from here. So it will be filter. It has yet another input query option int limit. And if there's an error, we return a string body. If there's no error, then we return a list of books. Body and list of okay. Okay, so now this is slightly more complicated, right? We have a couple of inputs here, we have an error output, we have a normal output, but still, I think it reads quite naturally, right? If you try to, if you read this definition without knowing exactly the library, you can still more or less understand the invention. Okay, so let's get into this into a bit more detail. So you may wonder, how do I know, like, that I should use query in there, right? So that's a good question. So all of these methods, the query, the string body, the JSON body, these are defined in the Tapir package. So if you would like to get a list of them, you can just try Tapir dot, and here you have in the autocomplete, you have the whole list of values of methods that you can use. So for example, to define a path capture, the path segment that you want to capture as a value, you can use path. If you want to capture a cookie, you can use a cookie. If you want to capture a header, use header, and so on. So again, things that you would actually expect. So it's all autocomplete friendly. Okay, so now that we have a couple of inputs, how does this map to the type, you may wonder, right? And so we can actually try to write down the type. Actually, we have to get rid of the compilation error over here. Okay, so let's tackle this first. So here we specified that as the output, that will be a JSON body containing a list of books, right? To be able to use JSON bodies, we actually need a way to encode a result as JSON. Like we need a codec which will transform the list of books, the Scala value, into a JSON, right? So Tapir doesn't define another JSON library. We will simply use Warski. So to use Warski, we need a couple of imports. So we will import Warski generic auto. If you want to use another JSON library, that's not a problem. It's quite simple to provide integration of the two. And we will also import the Tapir JSON integration, Warski, okay. So this import will automatically generate codecs for case classes, Warski codecs for case classes. So with this import, we will be able to encode a list of books as a Warski JSON value. And with this import over here, we will be able to encode the Warski JSON into a value that Tapir understands. Okay, so now this compilation error here disappeared, and we can explore things further. So as I said, here we have a couple of inputs, and each input as well as each output, each input can contribute a value that can be extracted from the request. Right? In the hello endpoint, we had a single query value that can be extracted. And that was then used in the server logic. So here we will have two. We have one which is from year. The second is the limit. But we also have an input which is a constant path, books, right? So this will be get/books from year and the limit, right? So that's the input we are defining. So this books over here corresponds to a constant path, and this doesn't contribute any values to the request, to be extracted from the request. And this is actually visible in the type. So now if we try to write down the type of this will be of type endpoint. Endpoint has 4 type parameters, which may sound scary, but don't worry, it's actually quite understandable. So the first type parameter corresponds to the inputs of the endpoint. Okay? Here we have two inputs. The first one is an int, the second is an optional int. By the way, if you use an optional int, that's an optional query parameter, which I think isn't very surprising. So we have two inputs, so it will be a tuple of two values, right? The second type parameter is the type of the error output. So here it's a string. The third type parameter is the type of the normal output, and here it's a list of books. And the fourth is streaming information, which we won't cover here, well, but it's there. And you can use it if you want. Okay, so that's the type of the endpoint. And this way, because we have full information of what are the inputs, error outputs, and normal outputs, we are able to define in a type-safe way the logic of the endpoint, right? So now if we try to actually define the logic over here, so let's remove this. We'll say getBooks endpoint dot toRoot, and you can see that IntelliJ has inferred that correctly, right? So in order to interpret this endpoint as a server, we need to write a function which takes a tuple of two values, the from here and the limit, and produces either an error value or a successful value, which is a list of books, right? And so we can write down the server logic. So we can say we have to deconstruct the tuple from your limit. And if from here it's 92, then we return a successful future. Of course, in the real world, you would use some kind of a database call, limit or 10, which is the default limit, and otherwise we return a future successful left and unknown here. Okay. And we have defined our the logic for our endpoint. And we can try running it, see if it still works. This will be useful later. Okay, and so I have some requests we can try here. And we can say that we want all the books from year 1992, and we get the 3 books, or we can try limiting them to 2. No. And I forgot the syntax. Multiple query parameters. Yeah. So this works fine. If we try to give another year like 1993, we get the unknown year error as specified in the logic. Okay. So far so good. Things work. So now let's explore a bit what these descriptions are. Okay. So again, a nice thing here is that the description that we define over here, this is just a normal Scala value, an immutable Scala value, which is a case class. There's a family of case classes which describe the endpoint, and you can treat it as any other case class. Okay? The whole API, the endpoint.get.in and so on, it's just a nice interface to constructing these case classes manually. You can construct them manually, of course, if you want, but it would be it wouldn't be as readable as using the helper methods and the helper functions over here, right? So if we go into the definition of the endpoint class, so let's look at the definition. You can see that it's a case class containing exactly what you would suspect, right? So it has an input which is of type endpoint input. It has an output which is of type endpoint output, and some metadata like the name and description, right? If we go to the endpoint input, it's a trait, it's a family of case classes, and there's a couple of implementations like at the header. So a header is a case class. There's a name for the header, a codec. So the header can be mapped to an int, right? So we need to encode as a string and so on. So each type of thing that you can describe in HTTP has a case class, right? And we can actually print our thing. So you will see that it's actually a K-Scala structure, right? So you can see that it's an endpoint. Here the first input is a multiple input containing a vector of inputs. So the request method input doesn't contribute any values to the type. The fast segment input doesn't, but the query does, and so on and so on. Okay? So if you are interested in some of the more technical details, the .in method, what it does, it takes a description of an input, right, a query of in here, and it takes the previous endpoint, so the endpoint defined so far. So here we have an endpoint with no inputs, and then we add one more input, right? So to do that, we need to take the previous input tuple and extend it with one element, here an int, right? So that's one place where implicits are used in Tapirs is for extending the input and output tuples. And another important note is that these values over here, so the query, the string body, the JSON body, these are helper methods which create descriptions of inputs and outputs. Okay, so the value returned by the query of int, it's also a K-Scala value, which you can use multiple times. You can, it's an immutable value, so you can treat it as any other value in Scala. And actually, we can do just that. So we can, for example, say that maybe you use the limit parameter in the multiple endpoints, right? So if you use it multiple endpoints, you can actually extract it as a value. So we can say that we will now define a limit input, and we will copy that. So we will copy it out, limit input, right? And we can say, well, we can extract it as a value and use it multiple times, right? It's an immutable value, so we can easily do that. Or maybe you have like all of the endpoints in your code actually use report errors as strings, right? So maybe you want to create a base endpoint which you can then specialize more. So we can extract this common endpoint structure into a base endpoint, which will be an endpoint error out string body, right? So that's like the base definition of an endpoint, and maybe each endpoint actually starts with the path books, right? So that's like the common structure of the endpoint, which we can then specialize later. So now we can refactor our code, and we can, instead of using the endpoint which is an endpoint, we can use the base endpoint value and return the things that occur multiple times, and we get a more concise definition, right? So here we can use all the standard tools that we use in everyday programming to actually achieve abstraction, which is like the simplest thing is extracting common code into a method or a value, right? So here we are doing just that, right? We are taking some common code and extracting it into a value like here, right? Okay. So once we have the server running, we can actually try to generate some documentation. So let's try doing that. And so we have interpreted our endpoint as a server. So now let's interpret it as documentation. So to do that, we will actually need a couple more imports and extension methods. So we will import Tapirs .OpenAPI, and we will import Tapirs OpenAPI first. I will explain why we need to in a second. Okay, so now we can take our getBooks endpoint. Okay, so that's the description of our endpoint. And the first import over here, so this is over here, as an extension method, which is to OpenAPI. And we need to provide a title, which we will call the title library, a version 1.0, let's say. Okay, so this extension method will interpret the description of our endpoint as a value as an instance of an OpenAPI class. Okay? The OpenAPI class, again, it's a case class, it's a family of case classes, which is a direct translation of the OpenAPI specification into a case class family. Right? So, thanks to this intermediate step, if you want to use some kind of OpenAPI feature that isn't directly expressible as the endpoint description, you can then amend the documentation, the generated documentation, in the same humane way, operating on typed classes. Right? You have in the OpenAPI case class, you have all the definitions that make part that compose the OpenAPI specification. So once we have this OpenAPI instance, we can then convert it to YAML. So to convert it to YAML, we will call the docs to YAML method, and that's the second import over here. We can also convert it to JSON if we prefer. Okay, so now we have the YAML. We can actually print it, just to convince you that it's actually generated. And here is the, if you have worked with OpenAPI or Swagger, you probably recognize it. That's the YAML corresponding, the Swagger documentation corresponding to our single entity. Okay? We can also add some metadata. For example, if quite often, if you would like to document our API a bit more. So here, for example, we can say that we want to add an example. So we can say that the result will be a list of books, a JSON body, and an example of a result will be a list consisting of a single single book. So you shouldn't use head in production code, but it's demo, so it's fine. So you can provide an example. You can provide a description of the endpoint, description, and gets books, which isn't very surprising, but you can describe the endpoint to the user. So you can provide some metadata, which will be later included in the documentation. Okay, and finally let's expose. So we have the YAML, the raw YAML, but we still have to expose it as a Swagger API. So we will compose. Right, YAML roots. Okay, so and we need to import some magic directives. Okay, so I have a Swagger UI class, which is just which are just archive TP roots, which read all the Swagger resources like the HTML, the CSS, the images, and so on from the Swagger jar, and expose it under /Swagger. And it also serves the YAML that we have generated. So it's just a helper class to expose the whole Swagger UI. So now we can run this one. And so this runs. So now let's open the browser and let's go to /Swagger. Okay. And we have the Tapir library. We have a single endpoint, which isn't much, but it's there. And you can try it out. You can say that on books from year 1992. And we actually got the result over here, right? And if we look at the parameters, so for example, here we have an example value of the book, right? So it's a single book that we have said, that we have defined, right? Here we have said that we took a single book somewhere here, right? So that's the first book, and it serves as an example. So this all works quite nice. Okay, so this works. One more thing that you can also do is generate client code. So let's concentrate on the part over here. So you can actually generate an HTTP request based on an endpoint description. So we take our endpoint description, we call to HTTP request, we need to provide the base address, which we will call. And now this, like to generate a server, we needed to provide a function, which would be the server logic. Now the client works the other way around, which probably isn't surprising again. It generates a function, right? It's a function which we can apply to the input parameters and get the output parameters, right? So here it's a slightly more advanced example, but the book filter is basically the year and the limit combined in a single value, to map values together. But yeah, but we can if you run this request, you will actually hit the server. So we can actually start the server that we have written, right? And now we can try running the client as well. So invalid value, because I have changed here something. Well, that's one thing that didn't work in the demo. But at least it managed to connect. So that's part of the success. Because I wrote none here, and I need to provide it with some year 1990. Okay. So now we have a server running. I generate a server from client. No, that's an exception. Oh, it worked some time ago. No, it's because it's a different endpoint description. Okay, going back to the demo. Okay, so we have generated a server, we have generated documentation, we have almost managed to generate a client, and that's like the basics that you can do with Tapirs. There's of course a lot that I did not cover, but these are more like things that you would expect anyway. So I will just quickly show you a slightly more complex example, like over here, just to demonstrate. So you can do some quite nice things with the fact that the endpoint descriptions and the outputs and the endpoints themselves are values. So for example, like here, right, you can define a query parameter that maps to some value class. Here the year is a value class, so we can define a codec. You can define a codec which specifies how to map a string, which is what comes from the network, into your value class. And then you can use that as inputs. You can then combine multiple inputs into a single input, so you can take the year input, you can take the limit input, right? So you can take two inputs, combine them into a tuple, and then map them into a case class, like over here, right? So now you can create like compound inputs from simpler inputs, right? And then use it multiple times across your application. So you can abstract a lot of common things into nice packages and get quite clean code if you have a lot of endpoints. So like before, we have here the base endpoint, right, which contains some common things like the path, but also this, the error out here consists of the status code if you want to signal different status codes, and the string body, right? This is reflected in the type over here, and so on and so on. So it's like it's things that you would expect from this kind of a library. Okay, so maybe you could have any questions at this point. Okay, we'll jump to other questions. A second. Okay, so as a quick side note, what really is functional programming, right? I guess if you are coming into Scala, you hear a lot about functional programming, monads, and so on. But in fact, like functional programming is not about monads at all. It's a nice addition, that's true. But at its core, well, functional programming is about functions, right? It's functions which take values and produce more values, and quite often these values are functions themselves, right? So, like at its core, if you like, when I was studying computer science, I knew some Pascal, but the first thing I had to choose either the imperative part or the functional programming part. I had no idea what functional is. I knew that Pascal is imperative, so I took the functional programming route, and I learned them for like 3 or 4 years, functional programming, and we didn't cover monads, functors, anything like that at all. So the only thing we did is work with functions and values and functions as values and so on, right? So if you think about functional, if you hear about functional programming, it's not about monads at all. It is a nice addition, right? It's useful to reify side effects as values as well, but at its core, it's really about functions and values. And that's exactly what we are doing here in this approach, right? We define a value, an immutable value, which is the endpoint description, and then we have a couple of functions. We have a function to turn that description into a server, into documentation, and so on, right? And that's all quite simple building blocks that we employ here. Another very common thing in functional programming or in this approach at all is this separation of interpretation of the description from interpretation, right? First you describe something as a lazy immutable value, and then you interpret it. That's the case for Tapir, but also if you look at, for example, Monix, task, if you look at Zio, if you look at I/O, these are all descriptions of computations which you then interpret into real computations. That's also what Doobie does, for example, for database, right? In Doobie, you describe the operation that you want to run against the database, and only later you interpret them and actually do the queries, right? So this separation of interpretation from description is a very common theme in these libraries, not only in Scala, of course, but in functional programming in general. Okay, so coming back to a short summary of Tapir. So what we have seen is Tapir, which is a library for describing HTTP endpoints. It doesn't implement the HTTP stack itself, right? It's an API for describing the endpoints only. The hard work of actually parsing the HTTP request, binding and so on, handling the connections, that's all delegated to HTTP or HTTPS, depending on your preference. In the descriptions, you can include all the common things that you would expect. So extract, path, components, queries, headers, provides outputs, status codes, string bodies, JSON bodies, and so on and so on. There's support for authentication. You can use multiple forms. You can use streaming. So there's support both for AK streams and FS2 bodies. There's a couple of interpreters, 2 server interpreters, 1 documentation interpreter, and 1 client interpreter. The outputs are segregated, so that's a bit similar if you are familiar with Zio. So in Zio we have the error part and the normal output part, right? So here we have a similar situation. We have a dedicated error output and we have a dedicated normal output, which are usually distinct. You can enable debugging. That's actually quite a common problem in HTTP, that your request isn't handled by an endpoint, but you're not sure why. Right? It ends up going somewhere in some weird path. So that's quite often quite tricky to debug. That's why there's both customizable failure handling in Tapir itself, which provides a nice answer to the problem. I have 10 endpoints, right? And I have to choose one to serve the request, right? So I tried the first one, of course, and the path doesn't match. Well, then I tried the second. In the second, the path matches, but the query doesn't match, right? So now, if the path matches, but the query doesn't match, should I try the next one or return a bad request, right? Well, in OpenAPI, the default is that if the path matches, but the query doesn't match, you return a bad request. But if the path doesn't match, you try the next endpoint, right? And that's the default in Tapir as well. You can customize it if you want. I think it's the same default and corresponds to, I think, amount endpoints. That's not the case for HTTP and for HTTP. So I think that's an important difference as well. And finally, Tapir has stackable traits, which is a nice technique, not only for Tapir, but also if you work with Doobie or Cersei. So all of these packages that we have imported, these are actually package objects which extend a trait. If you have like your own preferred stack, if you, for example, use the HTTPS interpreter, the OpenAPI interpreter, and the Cersei integration, so that you don't have to import three, so that you don't have to do three imports when you want to use it. You can create like a my Tapir object and combine all of these traits into a single object, and then have as like a single import entry point to Tapir. And you can do the same with Doobie, right? You can take all the Doobie features that we are using, like all the decoders, all the database-specific integration, combine it into a single object, and have like a single import entry point into Doobie or into Cersei and some other libraries as well. Okay, and I have a slide n-1. Okay, like just to reiterate the goals. The main goal is to be programmer friendly. I guess the programmer experience when using the library is really important. That's why the focus, when we are writing Tapir, the focus was on creating readable code, right? Readable, but well, easy to write in terms of autocomplete, that you can actually use autocomplete to write down the descriptions, but also with readable types, right? Quite often the types in the functional programming libraries are quite scary. So I hope it's not the case here, right? There are 4 type parameters, which isn't ideal, but that's the type information we need actually to generate, to be able to type safely, generate a server or a client. So apart from the friendliness, then we have all the good parts that we know from HTTP or from the Java libraries, right? So we have a clear separation of business logic from the endpoint definition, from the description of the endpoint and its documentation, right? So these two are separated even more than with the annotation approach in Java. We have reusable, immutable data structures that we can use very standard tools to abstract over. Like we can create lists of endpoints, we can create lists of inputs that we can then work with further and manipulate them. And most things are type safe, so there are things that are not type safe. I would say that it's reasonable type safe, but of course it's for you to judge if your reasonable is my reasonable as well. Okay, and I guess that's all that I had. All the materials from the presentation are on the second thing. The library, of course, is open source, so please try it out. It's still in early stages, so if you have any suggestions on how to improve things, create an issue, come to Gitter, or come talk to me. There's quite a lot of documentation over here. There's, of course, a link from the GitHub page as well. The documentation is maybe not in, might be better organized logically, but all the information is there somewhere. And yeah. We are the publishers of Scala as well, my company, so if you don't know about the newsletter, check it out. And yeah, you can contact me on Twitter, of course, and thank you very much.